Hello programmers. Today I'm going to be doing a presentation for you. And the presentation is titled, What if AGI doesn't happen? And the topic is that question. What if AGI doesn't happen? Artificial General Intelligence. What if in the next 20, 30 years we don't get machines that can outthink us? What if all the gambles we're placing on AGI don't come through, right? Now, you might think this is outlandish, right? AI has been improving so fast, so quickly that it must produce AGI soon, right? But there are signs. There are signs that AGI might not actually be coming. It could be literally centuries away, or maybe never. And the main things that I want to talk about here are, first of all, we have a lot of failed AI predictions. We have a lot of predictions that were made by commentators and experts about when human-level intelligence AI would be available, and it isn't. AGI by last year, programmers are relevant by this year. It hasn't happened, guys. Despite many advancements, AIs still struggle with extremely simple tasks. If you talk to a lot of chatbots and you talk to them in depth about more complex issues and topics and problems, you'll very often find that they're demonstrating very critical comprehension problems, right? They don't really think very well, right? They take on very surface level analysis of things, right? And it's not entirely clear that we're going to be able to get LLMs past that, which are still the primary area of research. It's, in my opinion, I think that LLMs are kind of plateauing already. They're likely to improve a little bit more, but I think that in order for some sort of AGI type system to happen, we're going to need something more advanced than just token prediction. At least the kind of token prediction we have now. And many experts are uncertain that AGI will actually even happen, right? Many are aware that LLMs probably aren't sufficient. But even if that is widely recognized, even if the researchers finally get their head in the game, it's quite questionable. And as I said before, this is quite the gamble we're making, right? The entire U.S. economy basically is an AI bubble now. At least that's the way I understand it. I don't quite believe that the majority of the economy is actually just pumping money into AI, but looking from the outside, it can feel like it. So what if AGI doesn't happen, right? What will actually happen, right? First of all, there's going to be tons of money just wasted, right? People threw their life savings into NVIDIA stock or whatever, and when it crashes, I guess they lose their life savings, right? And in general, right, huge amounts of resources building data centers and whatnot will have been wasted. Billions of man hours will have been wasted trying to get AI working, right? Not just the man hours developing the technology, but also the man hours building the data centers, doing the paperwork, all this other crap. There's not going to be a hyper-exponential productivity curve, right? We're not going to have self-improving AI if AGI doesn't happen, right? There's not going to be a cure for cancer, no immortality serum, and I'm sorry, guys, sorry, Elon Musk, there's not going to be genetically engineered cat girls to marry. It's probably not going to happen. I put this on here as a joke. It's still kind of funny that he said that. And of course, no shareholder value. Line do not go up. I know that that's actually what they really care about right now. They're in their bed, right, thinking all the time, how can I sleep best for the shareholders? Those rich bastards. So, no cat girls? Probably. Saves us from buying litter boxes. It's probably for the best. But there is another gamble we can make. Very similar to trying to gamble on AGI. And the gamble we can make is on the power of nature. Specifically, the power of this little organ right here. This thing is the most powerful computer we know of, right? We don't know who made it. We don't know where it came from. But, it's the most powerful computer in existence as far as we know, right? We don't know of anything more powerful than these. And we have a lot of them, right? I happen to have one between my ears. It works so-so, right? Some people have ones that work better, But anyway, here's the idea. Here's the main pitch. What if instead of an artificial intelligence explosion, we try to create a human intelligence explosion? Now, that might not really make sense to you, right? How can we make human brains infinitely more intelligent? Well, I do think that there is actually a limit to how well we can use the human brain, and eventually we might have to do something like AGI, but it might not be this century, it might not be this 1,000 years. Assuming that trends go as they've been going so far, right? I propose that we accelerate the current process of, human advancement, which has already happened, which is already happening right now, and we crank it up to 11, right? And I believe there is precedent to believe that a human intelligence explosion this century is possible, right? We could reach our cognitive capabilities maybe before the end of the century. Maybe not as fast as AGI might be able to do it, but, that's if AGI could even happen, right? If AGI doesn't happen, this might be our best bet, right? Betting on the power of the human brain instead of the power of silicon brains. Human knowledge and understanding grew incredibly fast during the 20th and 21st centuries. Anyone who has even an introductory level understanding of history should understand this, right? The events of the 20th and 21st centuries in particular are completely unprecedented in the broader view of the past few thousand years, right? Nothing even comes close. Nothing compares, right? And I think we have a good grasp of why it happened. It happened largely because of improvements in communications technology and improvements in education and stuff like that. So basically humans were thinking faster, better, and more efficiently right now. Also there's stuff like the proportion of the population that had to be farmers went down, right? So they could spend their time actually thinking about things instead of picking crops out of the ground. Which is a far better use of human brains than pulling plants out of the ground. So I propose, again, like I said, all we need to do is take the existing process that has happened for the past century or so, slightly over a century, right? I'd argue it actually goes back to the 19th and even 18th centuries, and it's been building up. And here in the 21st century, we're at the pinnacle of it. All we have to do is take what's happening right now and crank it up to 11. Now, the question that you guys might have is, how do we do that? How do we take the existing process of super fast technological development, of super fast human intellectual advancement, and crank it up to 11? How does that happen? Well, I believe I have discovered a mechanism to do this, in a specific technology we can use to make human brains work superhumanly fast, superhumanly well, and solve problems super efficiently. And that technology is metaprogramming. And here, basically, the basic gist is, instead of making computers replace humans, instead of making them do all the thinking for us, we want to use computers to make humans better thinkers, right? We want to use computers in a way that assists us in thinking. So we are still the ones doing the thinking. It's just our thinking is better, more advanced, faster, and, then you fire lightnings out of your fingertips. This might not actually happen, but it might. How it works. Okay, so this is how it works, right? You start out by making better compilers. If you have better compilers, better programming language compilers, better any kind of compiler, right? Programming languages, as we imagine them, might phase out of existence. I don't imagine that text is actually the best medium for programs, but it could be. We get better compilers. This implies making software is easier, right? So writing software becomes easier, which obviously means we can write better compilers, right? And so this is a loop. This has this effect right here, more better software, right? So as software gets easier to make, we get better software in a larger quantity. The better software in a larger quantity means we can better use computers to do thinking work, right? Not only just, not just like AI type stuff. I also mean like visualization tools, creativity tools, even simple productivity tools, right? Even, like Microsoft Word or whatever, or LibreOffice, right? Programs like this, even, if we could make these better, that would, probably be pretty big for our overall productivity as thinkers, right? And this ultimately means we think better, we think faster, we think, we produce intellectual output better, right? And a side effect of thinking better is that we're better able to write software, right? If we are better thinkers, if our minds are more powerful, we can write software easier, right? Now, I do imagine that this probably has a plateau faster than the theoretical thing of, well, maybe we could build more advanced computer chips, right? Because the human brain can't really be physically expanded, right, as far as we know. Maybe it could be, and meanwhile, we could theoretically make faster and larger silicon chips. But, again, I don't think we're anywhere near the limits of the human brain. And I think that that's pretty defensible, right? That the human brain has a lot more power than we have tapped. Anyway, so let me explain here why compilers in particular, why compilers are I mean it, the key. The basic reason is basically that programming language compilers are the way that we talk to computers, right? And computers are basically machines which automate problems that we've already solved, right? So anytime that we have a problem that is basically just number crunching, that we know is just, do the calculations and you get an answer, right? The boring part of math. Computers automate the boring part of math, and it's a waste of human time to do the boring part of math, right? Because we already know how to do it. We can just get the computer to do it, and it's very easy, right? So this means that humans can spend their time thinking about things that actually matter. If computers are hard to use, if computers are hard to interact with, if it is hard to get computers to automate the stupid, just do the calculations part of math, then we have to spend time actually solving it by hand or in our heads or something, right? And maybe if you're a math PhD, that appeals to you. Maybe you like solving polynomials and whatnot. But a computer could do that for you. And it's not actually an incredible feat or anything, right? It's a feat in the same way that solving a Rubik's Cube is a feat, but we can get a computer to do it instantly. And you solving it is a waste of your mental effort. You could be spending that time thinking about actually meaningful problems that aren't actually solved yet. So current programming languages are weak. That means that they're not able to express the kinds of ideas that people have. They're terse, which means that when they do express the ideas people have, they do it very poorly, and repetitive, which means that it takes a lot of actual typing to type it in. Right? It takes a lot of characters. It takes a lot of keystrokes, and there's very often lots of repeated bits of information, right? You don't need to specify X 10,000 times, right? And this is sort of intrinsic in the nature of programming languages that exist, right? The ones that exist are very repetitive, and so it's very hard to efficiently tell a computer anything, right? Because it's very hard to build context with a computer and have it understand it in current programming languages. This all makes them hard to use and makes software hard to understand. So even once you've written a piece of software, just understanding the code that you've written, even for very simple applications, and believe me, basically all software that exists is truly simple. None of it is actually complicated. The only reason it is complicated from our perspective is because programming languages are so bad. And yes, I mean all programming language stuff that exists right now is bad. 10 to 20 years of the technology I'm proposing here will hopefully solve that, right? Or at least partially, right? More advanced compilers make computers more useful to us and make us more able to use them to assist our own analysis and thought, right? As programming languages advance, as programming language compilers advance, we see an improvement in our ability to create code to automate the easy part of math, right? The solved part of math, right? The part that we don't care about anymore, right? We know how to solve it. We just have to get a computer to do it, right? The key technology that enables us to make better compilers, that makes writing software easier, the thing that does not exist right now, or at least does not exist in the common space, right? Obviously, I have an implementation of this technology, but it's new, right? I created it a couple years ago, but it's new, in terms of like the greater sphere of humanity isn't introduced to it yet. We need a metacompiler. We need a programming language compiler which is fully programmable, both on the front end to accept arbitrary input syntax, in the middle so that you can perform arbitrary static analysis, right? So you need to be able to perform arbitrary transformations of the code. You need to have any number of intermediate representations that you convert into and then do static analysis on that. And you need to be able to produce arbitrary output. You need to be able to produce arbitrary output code. And I've drawn a little graph here. This is where the code goes, arbitrary input. Your source code goes in here. You make compiler extensions, things that are extend to the compiler. They're actually part of the input. They effectively add new steps to the compiler or new parts to the compiler to add new features, and then you generate arbitrary output, right? Which, again, as I said, is programmable, meaning that it is part of the input. You specified how the output is generated from the input. And the result that I predict from this technology, if it should be commonly adopted, if it should be widely used, is a human intelligence explosion, right? In the same way that these AI people are talking about, we're going to have an artificial intelligence explosion, we're going to have self-improving AI, I'm predicting the same thing, but instead of computers doing it, it's humans doing it. As computer software of increasing complexity becomes easier and easier to design, implement, maintain, and understand, which I think is like the biggest thing here, better visualization tools, scientific simulators, and data analysis tools will be written, right? As software gets so easy to make that scientists look at programming languages and say, hey, I could just write this in 10 minutes in such and such. They bang it out and, they get it running and they look at it and, they see like amazing visualization of their theory or whatever, and they say, I didn't realize that was true, and then they cure cancer or something, right? Or they fold a protein, or I don't know, right? Basically, science happens, right? More advanced compilers may not just make software easier to write. People may literally look at they may think in terms of the programming language elements that exist, right? Imagine 10 years down the line, people have invented super amazing programming languages that perfectly implement ideas from the human brain, from math, and whatnot, and they've basically made compilers work in terms of the things that people think about. Imagine that they've done that, right? And then that gives people concrete things on which they can anchor their thoughts, right? And that's going to enable them to think of things they literally couldn't think of otherwise, right? They're going to be able to have concrete things they can anchor their thinking on and say, if I combine this thing and this thing together, I can get that, right? And then they, have new ideas that they wouldn't have otherwise. Scientific discoveries will happen because people discover new ways of thinking about problems. This is what metaprogramming is really going to do for us in science, right? It's going to give us the ability to reason about math, right? I mean like really deep math. I mean the super theoretical, super, can we prove X? Can we prove Y? Can we prove that the angel escapes the demon? Can we prove, whatever, right? You've probably heard of like tons and tons. If you watch Numberphile, you've probably heard lots and lots of like weird math theorems. Whatever, right? Do the Black Knights win or do the Red Knights win? I remember I watched a video about that on Numberphile. I know that this is kind of distracted, right? That's an example, right? There was a video on Numberphile about, Red Knights and Black Knights from chess, and if you place them on spots on the board, and you say that it's not important. Basically, there's a whole bunch of problems in math which, if we had better compilers, it would be easier to think about how to solve them. Not only in terms of like we could write simulations, we could write visualizations, we can already do a lot of that, but also we could literally have compilers, that are so advanced that the language actually works in terms of things that are human reasoning ideas, right? And so we could actually have compilers solve math, like real math, the real deep math. And by solve it, I mean, like, first of all, we could literally have, like, static analysis that solves those kinds of problems. But also, I mean, like, the elements of the language could be things that when a human thinks about, they think about it, and then they think that, they transpose a math problem into that, and then they realize, oh, I can solve it this way, right? So why hasn't this happened already? Why? And simply put, computer scientists fumbled the bag, right? We kind of fucked up. And I say that right, because I am a computer science major. I don't have a PhD. I only have a bachelor's degree, but, a worthless degree, by the way. It didn't really teach me anything. But I mean, like, the most things that I learned from university were, like, were math, right? That was the best stuff. But anyway, back to the point. Programmers quickly realized during the 20th century that directly writing machine code, flipping switches on the front of their Altair 8080 was pretty annoying. And so they created assemblers, which just, makes a nice little syntax for machine code, right? It's basically a macro. Then they realized assembly was obnoxious, and then they made macro assemblers, which we call high-level languages, right? Such as C. And yes, I do insist that C is, in practice, little more than a macro assembly language, right? I have actually created macro systems that implement things from C, right? And, C does do some processing, but, in practice, the most advanced languages we have are basically just tiny steps away from assembly, right? They don't actually introduce all that much meaningful abstraction, meaningful thought, automated math, automated processing, automated programming from assembly language. You're still basically doing the same thinking when you write assembly language versus when you write C, versus when you write Rust, to be honest. We've only made tiny strides from assembly language. And while programmers have recognized over time the trend of abstraction, they recognized that, we go from having machine code to assembly language to C, and then they thought of C++ and objects and all this, and then they thought of containers in C++, and then in Rust you have even more complex weird things in Rust, right? They have realized this trend of abstraction, right? We do need new abstractions, but they never grasped the trend of vertically stacking compilers. And that's the real big thing here. We need to be able to implement arbitrary new processing, arbitrary new syntax, arbitrary new logic, arbitrary new encoding to programming language compilers. And that basically means new compilers. We need to have a compiler that allows us to write new compilers inside the compiler. We never got the metacompiler. But aren't there new programming languages all the time, you might say? If you look on GitHub and you look up compiler, right, you're going to find a whole lot of programming language projects out there, right? They exist. People are making them all the time. And believe it or not, there is a lot of important work happening there. But the truth of the matter is most of that work is actually wasted. People write new programming languages. They have ideas. They have the advancements that we need to make better compilers. It's just that when push comes to shove, those new languages that they make are completely unusable. They have zero libraries, they have zero support, and they have zero compatibility. So someone invents the Bacon programming language. That it probably exists. There's probably a programming language called Bacon. It's probably not actually about breakfast food. It's probably actually about, I don't know, whatever, right? But, and there might be some amazing new features in it that would make that, if incorporated into the broader sphere of computer science, would be useful, would be important. But because it's an entirely new language with zero libraries, no support, and no compatibility, people look at it and say, well, it's not that much more of an advancement, and we already have optimizing C compilers. So why would we switch, right? We have all the libraries we need in C, and so they don't make the jump. Another way that people make advancements is they take old languages and they write new compilers which implement like optimizers or static analyzers or linters or whatnot, or they write new libraries, and that is progress of a sort. But the thing is, there's a limitation to how far you can go with that. No matter how far you take an optimizing C compiler, an optimizing C compiler will never work in terms of how the human brain thinks, because it's always going to be C. It can't incorporate, for instance, even things from C++. It can't have structs. It can't have templated programming. Any of that. It's always going to be C, and that's a huge limitation. There's a limit to how far you can take B here, and there's a limit with how far. And with A, entirely new languages, you can go as far to the wind as you want. But unless you make such a huge leap in usefulness over the commonly available languages that people want to switch to it immediately, people don't switch. So that's why C and C++ and these other old fuddy-duddy languages, even COBOL still gets used, right? That's why these old fuddy-duddy languages still have their place, and that's why they still dominate. C and C++ still dominate, even though they're super old, and there are better languages out there in terms of like features and whatnot. People still don't want to switch because it's just not a big enough leap, and the commonly available technology just has more libraries, so people want to use that. If new compiler technology was as easy as pound including it into your existing code, people would do it. But it's never that easy. In order to get a new language, you need to have all the libraries you need to write your applications. You need backends for all the target architectures you want to compile for. You need support. You need actual, like, a community surrounding that language, which is going to make that language exist into the future so that future hardware platforms will be supported. You need compatibility with existing code, hopefully, right? If new language advancements are made, you want them to be added onto, you want them to be available, right? And with C and C++, you don't get any of the new advancements, right? Even with this new C++ and C standards, the kinds of incremental gains they make are laughable. They don't actually make any real progress. So computer science, compiler technology is basically being shoved through a funnel, right? Everything that goes into bucket A gets thrown away, right? No one uses the new languages. Any sort of real advancement in compiler technology gets thrown away. No one pays attention to this. It gets forgotten. It literally gets lost. No one pays attention to this. And anything that falls into this bucket is going through a funnel, not only in terms of like they have to be the old languages, but also in terms of like, there's only so many people working on these old languages that are actually sitting on the committees saying, oh, well, we are going to allow these features into C23. We're going to allow these features into C++ 26 or whatever. I don't know what C++ standard we're on now. I don't care that much. It's stupid. The result is stagnation. As I said before, C and C++ still dominate. Rust and Go barely innovate. Go, I'd say, is actually kind of backwards because it's a garbage collected language, and that's garbage. And even things like Rust, which does have a whole lot of improvements over C and C++, is basically only a minor incremental thing, right? Rust is a minor step forward. Thousands of attempts at better languages have been tried. And as I said before, if you put them all in one bucket, if you took all the wisdom from the, 40 years we've had since C89, well, actually, wait a minute. C89, right, 10 years would be 99, 2009 would be 20 years, and then 2019 would be 30 years. So we're slightly over 30 years, and we're getting close to 40 years. So 30-something years since C89. If we had had all the wisdom and all the knowledge of that stuff poured into a bucket, stir it up, right, figure out what stays and what goes. If we had all that wisdom go into one new programming language, yeah, we would have made massive improvements. But most of it was just lost, right? These thousands of attempts, all that time, all that effort people spent writing the D programming language, writing... there was a language I found on Codeberg a while ago called Horse64. People write compilers, right? People do try to innovate, but it's lost because no one pays attention to it. No one adopts the new ideas. People don't try it. Most programming language authors are their only user. Sad but true. And none become popular because they never actually offered enough improvement to push people to the new language. So you have this sort of trade-off effect, right? Where like every new language, people look at that new language and they say, is that so much better over this old thing I use that I'm going to switch? And then they look at the fact that the libraries aren't there and the community isn't yet there, and they say no. And that means that innovation is fragmented and lost. The best way I could basically describe this is maybe 1% of 1% of 1% of the active, programmer pool of innovation in compiler theory is actually being used, right? Maybe not that little, maybe 1% of 1%, okay? But it's a very, very small amount, right? Because of all the people working on compiler technology, 99.99% of all their work is completely pointless, completely useless, and will be completely forgotten almost as soon as they've written it. No matter how good it is, no matter how wonderful it is, people don't care. They're going to keep writing C++, and we're going to be stuck in the dark ages, if this continues. Programmers are stuck using primitive, immutable tools that hamper their productivity, both as coders and as thinkers. And that trend will continue if we continue to write C and C++ forever and ever and ever, okay? Right, and that is the path we are currently on, to continue using crappy compilers forever. I, have stumbled upon, been granted from above, whatever, a revelation, right? How to solve this problem. The world's first true metacompiler, right? It took me a long time to even to figure out what I was making, right? But I did make it, right? I typed it in, right? Can't say that I really thought of the ideas. Maybe an angel gave it to me. Maybe God did. I don't know. But here it is, right? Coder's Basilisk is the world's first metacompiler, right? If you go to the diagram here, it accepts arbitrary input, arbitrary output. You can do arbitrary processing in the middle, right? That's what Coder's Basilisk allows you to do. It has this thing called cogen code, which you can just imagine as being like C++'s comp time, but like actually useful and good. And it can perform any form of static analysis you want. It can It can be involved with parsing. And it's also what produces output code. So you can parse anything on the front. You can produce any code all you want on the back, and you can do anything you want in the middle. And that makes it the world's first true metacompiler. And we're going to go through some examples. So just brief examples of what this does, right? Here, this is this function. This is a function here declared in Coder's Basilisk. It's declared cogen, and that means it runs at compile time, right? So this printout here is actually going to print during compile time. Furthermore, it's not actually going to. It's going to run specifically during parse time, right? This gets invoked at parse time. While the parser is parsing this function down here, it'll see the @ QQQ, and it'll run this function. This p global is going to call this, and this is going to define a global. This parses at the global scope, so it's going to create this type here, right? This is a type being defined, right? And the semantics of this are not important. All you really need to understand is we can call code at parse time during parsing to implement new syntax. And this is an example of a new syntax I've written. This is a pretty printing syntax. What this does is it basically just automates the process of creating tiny little printouts, right? It's basically a replacement for printf from C or C++, without variadic arguments or anything like that. It literally creates the print statements right here, And this, each one of these, right? This is a domain-specific language for pretty printing, and this is some code from the implementation of fprint, right? Specifically, okay, fprint is a variant on pprint, and this is the code for pprint. Pprint is the generic form, and then pprint by default works at compile time. It works with the compile time functions, and then fprint is a version which works at runtime, right? This generates runtime code. And here is part of the parser that I wrote. And this domain-specific language that I used here, with the slashes and the, like this is implemented in its own domain-specific language, which I wrote, which is designed to make it easy to write parsers, right? It's not quite a parser generator, but it's like, I'd actually say it's slightly better than a parser generator. This is a domain-specific language for writing parsers, right? And it could also theoretically, I guess, do AST generation too. It does it is designed to do that, but And also the code generator, the back end of the compiler, is programmable. Right here, this function call right here, this emits C code. This takes the AST parsed from the unit, and it emits C code. That means we can make it generate anything we want. We can generate C, we can generate COBOL, we can generate x86 assembly. Here I just have it emitting GNU C code. Specifically GNU C because there are some features of Cutter's Basilisk which I implemented using GNU specific features. Anyway, that's the video. I want to thank you for watching my presentation. The project is public domain. It is my gift to you. Steal it, take it. You don't have to attribute me at all if you don't want to. I do like being attributed. I do think that is a nice thing for you to do for me. But if it's in your way of just using what I've given you, then don't do it. Take it, right? This technology needs to be used, right? It needs to be used so that we don't stay in the hell that is programming C and C++ forever and ever and ever. Okay, we want to advance as programmers and finally be writing something meaningful or interesting, and not just barely above assembly language. And if we do not get AGI before the end of the century, I believe that the metacompiler as a technology, maybe not CBAS specifically, but the metacompiler will be the most important technology of the century. Thanks for watching.